Hi, have you ever wondered how one tweet goes viral and other doesn't, even if it is funny? And how one Instagram post reaches its sweet engagement spot and other just tanks? Today, let me tell you about logistic regression, a powerful machine learning technique which helps predict this. And I hope everyone can grab something out of this video, so stay with me till the end. So, what is this logistic regression? Logistic regression is a classification algorithm at its heart. Imagine you have a yes or no question, then logistic regression is always your friend. Unlike linear regression, which predicts only numbers, logistic regression predicts probabilities. And to do this, it uses sigmoid function. This sigmoid function is like a squashing machine which takes numbers, huge to small, which might as well be negative, and squashes them between 0 and 1. Why only 0 and 1? Because probabilities are always between 0 and 1. Now let's solve a cool example. Imagine you are a social media manager and your boss comes and throws 100 memes at you and asks you to predict which memes are going to go viral and which won't. To do this, we have to follow a step-by-step process. First step would be to define the features of the meme, which would be counting the number of text, matlab the words, the number of hashtags used, the number of emojis, and the sentiment score of the text and the time of posting, like if it will be in the morning, night, or afternoon. After defining these features, our second step would be defining the target. Here we can keep 10k as our target, which means that if the meme is reaching 10k likes or more than 10k likes, then there is a high probability that it might go viral. And if it is not reaching 10k likes, then there is a low probability that it might go viral. And the third step would be data preparation. In data preparation, first we have to clean the data. Then we have to calculate the sentiment scores of the text. Here our text is in caption, so we have to score the caption. So if we are giving a positive caption like I had a nice day, then the sentiment score would be 1. But if we are giving a caption like I had a boring day, then the sentiment score would be -1. The next step would be converting the time of posting to numbers. So we can give morning as 0, afternoon as 1, and night as 2. After this, our third step would be scaling the features. To do this, we'll use the standard scalar. It might sound little bit fancy, but it isn't, which means that we are making sure that no larger number overpowers a smaller number. For example, we'll have the word count between 0 to 500 and we'll have the sentiment scores between -1 to 1. We'll make sure by using the standard scalar that all the features are centered around 0 with a standard deviation of 1. Our fourth step would be training the model. For training the model, we have to give data about memes which we already know about. The data will include the features like the number of words used, number of hashtags used, number of emojis used, the time it was posted, the sentiment score of the text, and also the answers if it went viral or not. Then we have to train the computer in such a way that it understands the relationship between these features and the chances of going viral or not. For this, we have to calculate the coefficient values of each feature. These coefficient values just tells us how much each feature actually matters. Then after calculating these coefficient values, the system won't understand what these values actually are. So it will keep taking guesses, it will test the values, and also it will keep adjusting the coefficient values so that the calculated probabilities will be somewhat closer to the probabilities which we actually have in our data. And to do this, the model uses a MLE, which is a maximized likelihood estimation. So in short, we can say that we are giving data about the features and also the answers, like if it went viral or not, and the MLE will keep adjusting the coefficient values so that the model says that there's a high probability if the meme goes viral, and if there's a low probability if the meme doesn't go viral. And this is how logistic regression model training is done. Then our fifth step would be prediction. Now we'll give a brand new meme to the model and it will predict if it will go viral or not. It will print in such a way that there is a 80% chance that this meme will get 10k like. So after this, our final step would be evaluation. Why are we doing this evaluation even after getting the output? We are doing this only to find out how reliable our model is and how useful it is for real world applications. For this, we have to calculate precision, recall, F1 score, and ROC score. What is this precision? Precision is calculating out of all the memes which we predicted to go viral, how many actually went viral. And recall is calculating out of all the memes that went viral, how many did we catch. And F1 score is a balance between the precision and recall. Then comes ROC curve. It just tells how good our model is at separating yes from no. Just like any other human being, logistic regression also has its own limitations. It always assumes that there is a linear relationship between the features and the coefficient values, and it can capture only individual interactions. Like it can only predict that if you post it in the morning, there is a less probability that your meme will go viral, but it cannot capture the combination or the interaction between the features. Like if you're posting a meme in the morning with an increased number of emojis, there is a chance for higher engagement, but this our logistic regression cannot predict. So in such cases, we can use models like decision trees and random forest. So whenever you're posting a meme or a post on Instagram, know that there is a logistic regression predicting if it will go viral or not. Just kidding. But this is how businesses predict churn, predict if a user is going to click the link or not, and also predict if the customer will buy a certain product or not. So that's it for this video. Thank you.